And A, question 13. Two transformations are said to commute if applying the first followed by the second gives the same result as applying the second followed by the first. Consider those four transformations of the coordinate plane. The first one, let's call it 1. Translation 2 units to the right. Second, a 90-degree rotation counterclockwise about the origin. Third, a reflection across the x-axis. Finally, a dilation centered at the origin with the scale factor 2. Of the 6 pairs of distinct transformations from this list, how many commute? So this question is about coordinate units and also transformations. So let's make sure we get how each of them works, because once you get that, then it's sort of like checking them one by one. There are 6 combinations, so you'll be able to figure out how they change, right? Which one does commute, which means first, second is the same as second, first. But let's firstly make sure we understand what is each of them. So for that, I'm going to draw a coordinate system. X and Y. Let's see, you have a point which is AB here. What does the first one do? Well, the first one is a translation 2 units to the right. So relatively straightforward. You will add x by 2, your x coordinate by 2, which means if you start from AB, you're going to get A plus 2, then B. Okay, the second one is a 90-degree rotation counterclockwise about the origin. That's where the picture helps. So if you are here, AB, and counterclockwise rotation by 90 degrees, going to be here. What's the effect? Well, you will find this distance A is going to be the same as this. And similarly, this B is going to rotate to here, right? So B is here, and that's going to be here. So start from AB. You are going to get minus B and A. Again, here, what you are trying to do is when you do the rotation, you find this line gets moved to here. So B becomes a negative B, but for X. And similarly, this A changed to here. So you'll get minus B and A. Now, reflection across x-axis. This is straightforward. You are here, you treat axis as a mirror. You're going to be reflected downward to here. So that's your 3. This is 2, by the way. This is 3. 3 is straightforward. You're only going to change x to negative x. Sorry, change y to negative y, which means you're going to change b to negative b, but a stay the same. So this is going to be a negative b. Finally, a dilation centered at the origin with scale factor 2, which means here's origin. You basically take this line and scale it by 2. So you're going to push this point to 2A, 2B. All right. That's a foundation for this question because stepping them one by one, if you get what each of them is changing the coordinate, you only need to be very careful, do it slowly, correctly, but make sure you understand how each of them is changing things. My personal experience is that the second one, the 90-degree rotation, is the most difficult one. So make sure you follow it. How we get it is by tracking how each distance is being moved around. All right. Now let's see if you do 1 and 2. Okay, first one is 1, then 2. You will start from AB. After you do 1, you get A plus 2B. But then you do 2. 2 will basically change it into minus B, A plus 2. So that's 1, 2. Then let's check 2, 1. 2, 1. You're going to start from AB, but this time you get minus B, A. And then you do 2. Sorry, then you do 1. You're going to add x by 2, so minus B plus 2, A. They are not the same. So do not commute. Now let's try 1, 3. Same thing. If you do 1, 2, 3, you start from AB, then you get A plus 2B. 3 is going to do a reflection, so you're going to get A plus 2 negative B. To save some space, I'm going to do 3, 2, 1 here. 3, 2, 1. You're going to get A minus B first. And then you move to the right to get A plus 2 minus B. So 1 and 3 actually do commute. Now let's try 1, 3, 1, 4. From 1 to go to 4 first, you'll get A plus 2B as a first step. And then your dilation. Dilated, you time everything by 2 to A plus 4 to B. Vice versa, 4 to 1, you're going to time by 2 first, so 2A to B, and then you add up 2, so 2A plus 2 to B. So y is the same, but x is not. One is 2A plus 4, one is 2A plus 2. Continue on, I'll do the next few ones a little bit faster. So 2, 3, 2 to 3, you're going to get minus B, A, and then minus B minus A. Vice versa. 3, 2, you're going to get A minus B first, and then B, A. 2, 3 also does not commute. Then 2, 4. You'll get minus BA first, then you do 4, you time everything by 2, minus 2B, 2A. And then vice versa, 4, 2, you'll multiply everything by 2 first, so 2A, 2B first. And then you do the rotation, you're going to get minus 2B, 2A. So this one also works. Last one, 3, 4, I need to do it in the top of the page. So 3, 4. 3 to 4 first. If you do 3, you get A minus B. And you do 2, you multiply everything by 2, you get 2A minus 2B. Now again, if you do 4 to 3, then you start from 2A to B, and then 2A negative 2B. So 3, 4 also works. So altogether, 1, 3, 2, 4, 3, 4. 3 of them to commute.